Hello guys, let's solve this math problem before us, which read x plus 3 to the power of x equals to 10. Then what is the possible value for x? So please, if you are new here, kindly subscribe to this channel, and by the time you subscribe, don't forget to turn on the notification button so that you get notified whenever I drop videos on mathematics. Okay, let's see how we can solve this challenge. So we say solution. Okay, we can write the question, which is x plus 3x 3 to the power of x equals to 10. Okay, so before we solve, let's substitute some values into this. Let's assume some values of x, then substitute them into this, whether it's going to give us 10 before we solve. Because one amazing thing about mathematics is that if we are able to detect values and these values work for us, there is no need for us solving further. So if we say let x equals to 1, if we assume that x is equals to 1, then put 1 here. 1 plus 3 to the power of 1 is not equals to 10. Then if we assume x is equals to 2, then if we put 2 here, 2 plus 3 to the power of 2 is going to give us 11, and 11 is not equals to 10. And if we should do the same thing for 3, s equals to 3, we put 3 here, plus 3 to the power of 3 is going to give us what? It's going to give us 30, and 30 is not equals to 10. So we can't just easily assume the value of x in this challenge. We have to solve for it. So let me show you one of the methods you can easily use to solve out the value of x. Okay, since we've written x plus 3 to the power of x is equals to 10, the next thing you can do is by bringing this x to the right side of the equation. So if we should do that, we're going to arrive at 3 to the power of x is equals to 10 minus x. Okay, so we've done this, we can write this to be 3 to the power of x is equals to 10 minus our x. Okay, from here, what are we simply going to do again? So the next step you can take is by dividing both sides of the equation by 3 to the power of x. So if we should do that, we can say divide by 3 to the power of x, divide by 3 to the power of x. So if we should divide by 3 to the power of x, we are going to say 1 is equals to 10 minus x over 3 to the power of x. So this is what we are now having. Okay, from here we are going to apply a rule which says if we are having a over b, okay, is also equals to a times b to the power of minus 1. So if we should put this principle here, we can simply have this to be our 1 is equals to 10 minus x times 3 to the power of minus x. So this is what we are now having. Okay, from this point, we can simply write the whole of this here by saying our 1 is equals to open bracket 10 minus x close bracket times 3 to the power of minus x. Okay, so the next thing we can do again is by multiplying both sides of the equation by 3 to the power of 10. So if we should do that, we can say times 3 to the power of 10, okay, times 3 to the power of 10. Okay, from here we are going to apply a rule which says we are having a times a to the power of minus 1 is also equals to, or rather, a to the power of b times a to the power of minus c, okay, is also equals to a to the power of b minus c. So if we should put this rule here, we have this to be, so this will multiply this, it will remain the same. So we are having 3 to the power of 10 is equals to open bracket 10 minus x close bracket times 3, putting this rule here, becomes 10 minus x. Okay, so this is what we are now having. So what then is the next step? What then is the next step? Okay, at this point, we are going to apply a rule which says if we are having a is equals to exponent of ln of a, because this exponent will cancel this natural log, and we are going back to this. So if we put this principle here, we'll simply have 3 to the power of 10 minus x is also equals to exponent of ln of 3 or to the power of 10 minus x, bracket close. So if we put the place of this, we put all this at this point, so we have this to be 3 to the power of 10 equals to, open bracket, 10 minus x, close bracket, exponent of ln of 3, open bracket, 10 minus x, bracket close. Okay, so this is what we are now having. Okay, so from here we are going to apply another rule again. We are going to apply another rule which is called the Lambad W function. The Lambad W function says if we are having star, exponential star, and if we should take the Lambad W function of it, it's going to give us star. So this is one of the rules of Lambad W function. So if we should put the Lambad W function here, we're having 10 minus x exponent ln 3 to the power 10 minus x. You can see that this base is not yet equal to this power number. It's not yet the same, rather, to this power number. So what are we simply going to do to make it similar? So the easier thing we can do is by multiplying both sides of the equation with the natural log of 3, which is ln 3. So if we should do that, we are going to arrive at 3 to the power of 10, okay, times ln 3, okay, equals to ln 3, open bracket, 10 minus x, bracket close, okay, exponential ln 3, open bracket, 10 minus x, close bracket. So this is what we are now having. From here, we can now apply the Lambad W function. But before we apply the Lambad W function, let's rearrange the whole of this equation. So I can write the whole of this to be ln of 3, open bracket, 10 minus x, close bracket, exponential ln of 3, open bracket, 10 minus x, close bracket, equals to 3 to the power of 10 times ln 3. Okay, so this is what I'm now having. So from here, I can easily apply the Lambad W function. So if I apply the Lambad W function here, I'm putting the W at this part, apply the Lambad W function here also, putting W at this part. Okay, so if I should apply the Lambad W function, we can assume the whole of this. To be the star. We can assume the whole of this to be the star. We can assume this ln 3 bracket open 10 minus x to be star, because we say star exponential star is going to give us what? To take the Lambda W function of it, we are going to arrive at star. So if we take the Lambda W function of it, we are going to arrive at ln 3 bracket open 10 minus x close bracket equal to the Lambda W function into 3 to the power of 10 times ln 3. Okay, so this is what we are not having. So let's solve further. Okay, since we are not having this, we are not having ln 3 bracket open 10 minus s close bracket equals to Lambda oblique function into 3 to the power of 10 times ln 3. Okay, the next thing we can do is by dividing both sides of the equation by ln 3. So if we should do that, we are going to arrive at 10 minus x, okay, equals to the Lambda oblique function into 3 to the power of 10 times ln 3, okay, or divide by ln 3. Okay, from here we can look for the value of x. So if we look for the value of x, we can say minus x is equals to Lambda oblique function into 3 to the power of 10 times ln 3 or divide by ln 3, okay, minus 10. Okay, we cannot see that we are having a negative sign here. If we should divide both sides of the equation with a negative sign, our x is now equals to the Lambda oblique function, or rather, 10 minus the Lambda oblique function into 3 to the power of 10, okay, times 3 to the power of 10 times ln of 3 close bracket over ln over 3. So this is the value for x. So if you punch the whole of this into the Wolfram Alpha calculator, your value of x is going to come out. So you can do that for me, and if you do that, drop that on the comment section below. So if you find this video useful and interesting, please click on the subscription button, turn on the notification bell. God bless you. Jesus loves you. See you in my subsequent video. Bye bye.